Hello. Now in this video we'll see examples of let's say well-specified quality requirements for frequently, let's say commonly occurring quality attributes. Okay, and we'll do some sort of a play with you. What I'm going to do, I'll show you an example first, and the list is here, as you see, a list of quality attributes that are relevant. What I would like you to do is to, as soon as you see an example, please freeze or stop the video and try to think which quality attribute does this particular example refers to. Okay, deal? Let's start. Now this is the example. Let's say you'll see which one it belongs to, but let me read it. After 1 hour of training, the user shall be able to complete 20 data entry with an error rate less than 1 in 20 in no more than 30 minutes. Okay, that might sound a bit long one, and that might be a little bit like a kind of detailed, but this is one of the best ways, I'm afraid, to show how usable or how easy to use or how user-friendly your system is. So basically this is usability, how easy it is for potential users to understand, to use, to really remember how to use your system. And that's one of the ways, this example shows one of the ways to really come up with something that is really measurable. That's not very, I must say, the way the statement is formed is not very, let's say, easy, or it might sound a little bit tedious, but it is, yeah, that's how we do it, unfortunately. So if you really want to come up with something measurable, concrete, that is what it is. It comes with some difficulties. Okay, this is also, as I kind of hinted you, it's also called ease of use or user friendliness, and that's a big topic in itself, essentially. So it's just an example here, but it's a huge topic. Usability, coming up with user-friendly systems. You'll see more slides about usability later on in the course handouts, but just remember the very first example I gave at the very beginning from the first video about the Mac, or let's say iPhone and Windows mobile phones. At that time, they basically even though the iPhone version was not would not come close to the extent of functionality proposed by the Windows mobile phones at that time, they still outperformed the mobile phones, basically because of the usability that they offered. Anyway, let's keep the usability apart. Now, the second example, the interpreter component of that particular system shall parse at least 5,000 error-free statements per minute, or 95% of the transactions shall be processed in less than a second. What could be? So if you're talking about like speed type of things, if you're talking about this number of things to happen in a certain period of time, it's very likely that you're referring to performance. Okay, so how quickly and predictably the system responds to user inputs or other events. Performance, again, you'll see more information about performance in the handouts. So I'll very quickly going through each one of these, not all, but the commonly seen ones. System shall be able to import a valid BPMN version 2 process model file generated by Bizarre version whatever, and Signavio version 9 or whatever process modeling tools. Okay, there's a mistake there, so version 9 and 9.1 perhaps. Anyway, so this is the statement that we put forward for which of the quality attributes you think. Interoperability, how easily the system can interconnect and exchange data with other systems or components. So that refers to the ability to system to, again, exchange data, and whether you're using some standard data exchange mechanisms to ensure that. Next, After performing a file backup, the system shall verify the backup copy against the original and report any discrepancies. Or the system shall confirm that an encoded structure of a BPMN version 2 process model file imported from a third-party process modeling tool, reference whatever that tool is, represents a valid structure. Which one do you think? It's integrity, the extent to which the system protects against data inaccuracy and loss. And as you may guess by now that in fact some of these statements might as well be let's say translated later on into functional requirements, because we expect system to do something, but not necessarily. Okay, just keep that in mind. Another one. Train acceleration control software shall have a mean time between failure of the order of 10 to the 9 or whatever that number is, millions, I guess, hours. Okay, or no more than 5 experimental runs out of 1,000 can be lost because of software failure. Reliability, and that is again yet another topic that is very important, and that's a huge, and it's basically unfair to just show one slide and that's it. It's not. In fact, in the handout again you will see more information about reliability. Again, what is reliability? How long the system runs before experiencing any failure, and particularly if you're talking about like mean time to failure type of like metrics that you can use, that's reliability. And it's very, very closely related to robustness and availability. And this is a huge concern, obviously, for let's say systems that require high reliability, like air traffic control system, magnetic resonance systems, or flight management systems, and so on. So I mean, you can't simply expect the same level of reliability from these systems and from those that you use in mobile phones. Okay, I mean, it won't hurt you if your mobile phone application just collapses. Fine, we see that daily in some cases. It used to be worse, but anyway, so right now you can't simply expect that level of reliability in those systems, air traffic control systems. So it's a huge topic. Spend some time to read the later slides. System must be 100% operational 99.9% of the calendar time during its first year of operation. Or the system shall have at least or have less than 1 hour downtime per 3 months. What is that? It is basically availability, to extent which the system services are availability. Again, I mean, obviously you would want your system to be available all the time, 24/7. That it might not be possible in some certain conditions. So you might need to do some backups in your system, you might need to do some maintenance in your systems, and that's the reason why, for instance, sometimes we go to a website and it says like under maintenance or something like that. We apologize and so on, and that's basically the time that system is not available, and we don't want that system to be unavailable all the time. So we need to put some, let's say, conditions on under which that system, or it is okay to make it unavailable. Okay, fine. Let's see the next one. If the editor fails before the user saves the file, the editor shall be able to recover all changes made in the file being edited up to 1 minute prior to the failure the next time the same user starts the program. That's a very long sentence. I didn't like it at all, but whatever. You might sometimes, of course, you try not to come up with such long statements, but sometimes it's unavoidable. What is this? Robustness. How well the system responds to unexpected operating conditions, or software's capability of maintaining a specific performance level, which is very important, in cases of operation faults, which is also known as fault tolerance. Okay, So what kind of metrics you can use? Time to start after failure, percentage of events causing failure, or probability of data corruption on failure are the metrics that you can use to specify, let's say, requirements that are measurable. Good. This one, the system shall lock a user's account after 4 consecutive unsuccessful attempts within a period of 5 minutes, or the system shall log all the attempts to access secure data by users having insufficient privilege levels. I think that's relatively easy. That refers to security, how well the system protects against unauthorized access to the application and its data. Security, and obviously that is very important, as you would know. More examples in the handouts. I think that's the last one. The product shall be capable of processing the existing 100,000 customers. This number is expected to grow to 500,000 within 3 years. Or the product shall be able to process 50,000 transactions an hour within 2 years of its launch. Sometimes it's also kind of confused with the performance, but it's not like that. So we really kind of project our expectations for the future, and we would want system to be scalable. How easily the system can grow to handle more users, transaction service, and other extensions without any performance degradation. So I mean, without any kind of a observable performance decrease. That's scalability. And basically these sets of attributes are the commonly known ones that we see in practice to be quite relevant and frequently referred to. And that is it for this video. We'll have, you'll see me in the next one.